Class, and welcome to Review for Exam Unit 6 Sinusoidals. This is one of my favorite units simply because it's new and it's usually easy to comprehend. If you've been following the function modeling so far, sinusoidal is just another function, another continuous function that we can either apply transformations to or do the same mapping sequence. But it's kind of neat because you can visualize it in real life. So that's why I really like sinusoidal functions. If you forget totally what a sinusoidal function is, imagine yourself on a Ferris wheel going round and round, and that we're measuring your height over time. Okay, and if we're measuring your height over time, you're going to get on, you're going to come up to a maximum height at the top of the Ferris wheel, you're going to come back down to a minimum, and you're going to go back up and come back down. Okay? We did learn through this repetitive functioning or repetitive patterning that we can call it what's called a periodic function. A periodic function has a cycle, a period, an equation of axis, an amplitude, a min-max, and a range. You should be able to tell me that based on a graph, based on an equation, or a situation. Okay, then we focused on what's called sinusoidal functions. Sinusoidal functions can be related to one of the two base graphs. So y equals sine x, and when you're graphing that, ladies and gentlemen, your first, middle, and last are on the axis. So if I quickly draw an x and y here, that's where you start at the axis. You usually go up to your minimum, you come back down, and it's a continuous one. However, I will just show one wavelength here, or one complete cycle, I should say. Okay, so just remember, it goes, for the base function, it goes up to 1, down to -1. Okay, and remember that when you draw your sinusoidal functions, this is a continuous pattern. Okay, so that's called a continuous function. But quite often, I might say, explain how you graphed it, and you would box in one cycle, so you could show me how you've graphed it. All right. So any function that's a sinusoidal function can be related to either this sine graph or the cosine graph. And the cosine graph I'll do probably right here. Okay, the cosine graph, it starts at its maximum, so it starts way up here, goes down, and then it comes back up, and it keeps going in that patterning, guys. Okay, likewise the other direction. But again, if you're graphing this and you probably want to show me one complete cycle, it'd be that box there. And again, it goes up to a maximum 1 and a minimum of -1. And the period of that is regularly 360 degrees. Okay, so here are the similar properties. I apologize for writing over top of that, but similar properties for both those functions, ladies and gentlemen, is that the period is 360 degrees. The amplitude is 1. That's the distance between the axis, and in this case, the axis is the x-axis in both cases, which is y equals 0. Okay, the domain and range are both going to be the same. All right, if we deal with what's called transformations, ladies and gentlemen, either we take that sinusoidal function, if it's a base of sine x or a base of cos x, and we shift it left, right, up, down, stretch, compress, reflect, any of that, we have to know some of these key formulas. Now, before on your unit test, I know I posted them up on the board, but you're going to need to know these for the exam. But I don't think they're that hard because they make sense if you can visualize things. So make sure you know all these formulas, okay, and how to relate it to A, K, D, and C. Okay, let's take a look at an example here. So here is an example, y equals -1/2 cos bracket 12 bracket x minus 14 closing bracket plus 1/2. The good news here, folks, is you've checked and you notice that k is already factored out. If it's not, you got to do that. Remember to do that, right? Okay, so that's the good news. So based on our transformation, okay, what letters do we recognize? Well, first of all, the first value we have is A, so A equals -1/2. Okay. We then look at our next value, which is K, so K equals 12. But we can use that to help us figure out the period. Because the period, if you look up here, folks, oh, sorry, let me move one more up. Not that one, I'll just erase that one. If you look above that one where I just started, period equals 360 divided by the absolute value of k. So it's going to be period. To find the period, it's going to be 360 divided by 12. So the period equals 30 degrees. It's going to help me when I graph. What else do I know? If I look at my other letters here, I've got D equals negative 14. I apologize, just 14. The negative is part of the formula. So D equals 14. And the last one we have is C, and C equals 0.5. Now remember, C tells us what? Okay, C gives us the axis. So I know my axis is y equals 0.5. So I'm going to actually draw that in to start with. Okay, what other pieces of information I know? I know that D is my starting point. So from there, I'm going to draw my graph, and then I'm going to take 30 degrees. I'm going to go 30 more from it, okay? So if I'm starting at 14 degrees, that's going to be the start of my box. So I'm just going to draw the start of the box. And because I'm going 30 more degrees, the end point's going to be 14 plus 30. So if you want me to write that down, end point equals your starting point, which is 14 degrees, plus your period, which is 30 degrees. So that equals the end point is at 44 degrees. So my end point here is at 44 degrees. Okay. All right. The next thing we have to realize is taking a look at A. So we've got our box in here. Okay, we know our base is cos, right? So don't forget to write that down. So our base is y equals cos x. If you're not sure, strip away a, k, d, and c, and guess what you're going to have? Y equals cos x. Okay, but you got to be careful. The base is y equals cos x, but a is what? Negative a half. So the negative tells us two things. Okay, so a is negative, which means instead of when you have y equals cos x, you start at your max. Therefore, you're going to start at min for cos x, because it is reflected, right? All right. Okay, so if you want to think about, hey, what's my maximum height? Maximum, according to our formula, equals c plus the absolute value of a. So we know c is 0.5 plus a half. So a half plus a half equals 1. So our maximum value is going to be 1. And our minimum value is going to be equals c minus the absolute value of a. So that's going to be 0.5. And we are going to subtract a half, which is still 0.5. So our minimum value equals 0. Okay. So we start at a minimum. So we're not starting at the y-axis. Remember, we're starting at our starting point, which is right here. So at there, it tells me I need to be at my minimum, which is at 0. Okay? And if I start at my minimum and I complete one cycle, I need to also end at my minimum. Okay? And then I need to get to my, because it's cosine, I need to get to my maximum halfway between the two. So if you take, okay, I apologize, I have this line wrong. It should be at 44. Sorry, guys. Sorry, hopefully you got a pencil. You can erase that. Sorry, I can't change those. My fault. Just noticed it was not at 44. All right, so if you take 44 and you subtract 14 and divide by 2, okay, you add them and divide by 2, or halfway between these two, if you figure out, it's going to be right here at 29. So 29, they need to be at its maximum, which we calculated to be 1. Okay, and again, we're going to complete one cycle in our box. Okay, so I'm going to do that. That's its, I know that's its minimum. I'm going to go up to its maximum and down to its minimum, and I'm going to keep kind of growing like that. As long as you show me one full, I'm okay. Depending on your graph, if you could show me two, that'd be great. Okay. All right. So now I can box in saying, hey, here's where I started. Here's showing one cycle. Okay. And if you can label it, y equals -1/2 cos bracket 12 x minus 14 closing bracket plus 0.5. Sorry about having that 44 wrong, guys. Okay, hopefully you can forgive me on that one. All right, so there is a graph of that, okay? Again, take your equation, go AKDC, tell me what each of those means and how it relates to sinusoidal using the information above. Okay? If they had asked for domain and range, you would say that x belongs to set of real numbers, and you would say for range that it has to be less than or equal to 0, less than or equal to 1, and greater than or equal to 0, because it's going to be in that range. That's the only spot that that wave or that curve function will go. All right, flip to the next page, guys. All right, transformations. Again, I'm going to emphasize, know what AKDC does and how to draw them. Explain the transformations in words and change changes in the properties from the base function, from the base formula. So again, this is your sinusoidal transformation formula. It's either going to be cosine or sine. Okay, again, it shows you the placement of A, K, D, and C on both of them. Okay, make sure you know how to find the equations from the graphs and tables and know where to draw the box. That box shows me one wavelength, one cycle showing your starting point and your ending point. All right, so in your textbook, ladies and gentlemen, on page 398, just let me get there, we're going to do number 2 together. So just pause, guys, grab your textbook and take a look here. Okay, so notice there's a graph there, ladies and gentlemen, and the graph talks about different answers that you need to do here. Okay, so it's talking about Don Quixote is a fictional character in a Spanish novel, attacks windmills because he thought they were giants. At one point, he got snagged on one of the blades and was hoisted in the air. The graph shows the height above ground in terms of its time. Okay, so basically you need to look on this page at the graph, and we're going to take a look at some information. So the first thing we can figure out, looking at that graph on the left side, is what is the period, ladies and gentlemen? The period is the length of a time that it takes to complete one cycle. So you could look at maximum to maximum, minimum to minimum, or axis to axis. I think it's either good to look at the minimum to minimum in this case. So hopefully you've looked at the graph and you said, hey, period, guys, equals 20 seconds. So it takes 20 seconds for him to do one revolution, and that will allow us to then what? If we want to describe the transformations, we could relate that to K, because K equals 360 degrees divided by the period, which is 20. So what we're finding out, guys, is that K equals 18. There's one piece of the puzzle. Okay. The next, let's take a look at the axis. Where is the repetition occurring? Where's that mirror in the middle? Do you know what I mean? That allows it equal distance to the max and equal distance to the min. Looking at there, guys, axis, if you take your max and add your min, divide by 2, you'll get that, okay? So your axis is 10 meters, and relate that to what letter up above, therefore C equals 10. So we know 2 letters so far. Okay, now that we figured out our axis, let's figure out our amplitude. So the amplitude, ladies and gentlemen, equals the max subtract the min divided by 2. Okay, so So that's the max is 17, subtract the min, which is 3, divided by 2, so that equals 7 meters. Therefore, the absolute value of A, we haven't discussed if it's negative or positive yet, equals 7. So we're going to come back to that in a minute. Okay? So now if we're trying to come up with the equation, now we need to decide if you want what base you want. So if you want a base of sine x, so we'll do sine x over here, and we'll do cos x over here. Okay? Okay, so if we want to do sine x, let's just focus on that graph. Sine x means you start where? At the axis, and you're approaching your max. So let's take a look on that graph, guys. And if you try to estimate, it looks like for me that d equals 5 if we're going to go that route. Okay. So if we figured that out, we have to also say that if we're looking at d equals 5, is sine x positive? Yes. So when we do that, a equals 7. So we have all the information we can put in for the sine x curve. So if we have that equation, it's going to be y equals 7 sine bracket 18 opening bracket x minus 5 closing brackets plus 10. Or if you want to do cos x, that means you're starting at your maximum and you're going towards your minimum. So where do you first see a maximum? I would take a look at that and say probably d equals 10. So for that one, d equals 10, and a is positive in this case, so a equals 7. Okay, so taking a look, you'd come up with this equation and you would go y equals 7 cos bracket 18 times x minus 10, closing brackets, plus 10. I have one more example that you may have liked or recognized. Instead of using just cos x, let's make it negative cos x, which means where do we start at our minimum and go to a minimum? And that's where d equals 0. So you may have even chosen this one, which is okay. Okay. And if you're going to do that, don't forget that a is now going to equal negative 7 because we're doing negative cos x. Okay. So y equals negative 7 cos of 18x plus 10. Sorry, I got to fit that in there a little better. Because there's no, you're starting right at, your starting point's right at the origin. So your formula for that would be y equals negative 7 cos 18x plus 10. All right? So coming up with any of those equations, again, you can choose whichever one you visualize the best. I will double check it. Try to do one that's not like way off the graph that I have to like grab a graphing calculator for, but as long as it'll work, it will be acceptable. So I just grabbed a drink. I want to let you know that there's more than one possible answer because, as you know, these functions are cyclical, so that you could have a starting point anywhere along there, right? And then shift it accordingly. All right. For applications, apply all of the above to real life situations. Look for patterns over time, except example like 12 months or 24 hours. That should be or, I apologize. Okay. Usually deals with round things like wheels and tires. Just remember that if you got wheels, the radius is your amplitude, the axis is the axle or the spoke of the wheel, and you may want to remember this, folks, that the speed of a wheel is the distance over time. Okay, distance is the distance around a circle, which is your circumference, which is 2 pi r, over time, which is your period. All right, ladies and gentlemen, here is your homework. Okay, page 409, numbers 15 to 20, 26 and 31, and for the one on page 384, number 4, just graph them, okay, just to make sure you've got some clear understanding. And again, folks, please come see me if you need any help with this. Have a great day.